Hello, everyone. So I'm hoping you're having a great conference so far. Any interesting topics? Yeah, perfect. So hopefully we will add another one because I would like to talk with you about hallucinations, but not the pink elephant kind, but the digital kind. So let's all imagine a scenario. You are, this is not working. Maybe we can talk with the first slide only. Okay, thank you. Imagine a scenario. You are writing a simple bash script, and you need a simple regex for your code. So you ask your favorite AI assistant, maybe ChatGPT or Gemini, for help, and it will produce very helpfully the answer. And so you will copy it, try it out, and you find out that it doesn't work. So you complain. You said, this doesn't work in Bash. And the model says, oh, you're right. Of course, it doesn't work in Bash. And it doesn't really even know why it doesn't work. So congratulations, you've just been gaslit by a machine. So as it turns out, but this is not a random glitch, some random error in the model. This is something that is baked into the way how the models produce their outputs. And many experts believed for many years that this is kind of like a part of the models, that you cannot get a model without hallucinations. Up until now, because a few weeks ago, there is a new research paper from OpenAI claiming to find the root cause of hallucinations. And basically, what they are claiming is that there is an essential flaw in the process, how we are training the data. And I assure you that it will be super simple when I'm finished, and it will be super obvious in retrospect, like why this is happening. So this was a mystery for several years, but maybe right now we are closing in to discover why this is happening. But for us to understand why what this essential flaw is in the training data, we have to understand what the training process of these Gen AI models, how it looks like. And to simplify it, it consists of two parts. There is a pre-training and the post-training. The pre-training, you can imagine, is a process where AI learns everything. It reads whole internet, all the books, every recipe for a banana bread, like everything. It's basically like a teenager that you left unsupervised on Reddit for 3 years, and he just reads everything. And same way as some teenagers, it's not necessarily helpful at this stage. That's why the post-training comes in. And the post-trainings also consist of a few parts. The first part is called supervised fine training, where we as humans provide some examples to show the models what we are expecting of him. We are showing it some examples of helpful prompts so the model can learn what he should do. The second part, the model already knows what we are expecting, and he produces several outputs, and the humans, again, are validating if those outputs are correct or not. So they're evaluating good or bad answers, and what model is trying to do, it's trying to maximize his reward regarding this. So he doesn't necessarily want to be helpful, but he wants to maximize the reward. And here we are closing in to why the hallucinations happened. Because to maximize the reward, the model has two options, basically. It has two strategies that he can follow. The first strategy is that he can be cautious. So he can, if he is not sure or he doesn't know, he can answer, I don't know. And I will call, for the future reference, this model Albert. Or the second strategy, the model can be confident. He can try to answer also if he's not sure, or even if he doesn't know the answer. And I'm calling this model, maybe. I'm not calling this model anything. Is there another click? Oh, perfect. I'm calling this model, that there was a tension building. I did it on purpose. I'm calling this model Donald, because this is the strategy where he's trying to answer everything, that doesn't depend if he knows the answer or not. So these are two reward strategies the model can follow. So let's see how the model will be rewarded based on those two strategies. And there is a key piece of information, because the evaluation of those models are binary. So basically, the model can get only 0 or 1 point. There's nothing in between. This is how the process works. So let's find out how it will be rewarded. So the first model, and what the researchers in OpenAI, one of the way how they tested this was that they were asking about the birth dates of different people, and the people that were not famous, and the models should not know the answer. And they were testing the outputs. So the first model answers all the time, I don't know. And right now, in the training process, the I don't know answer is rewarded with 0 points. But the Donald, as you can see, he produces very different, very various, sometimes crazy, even 32nd of December, 8th of Donald Derry, different wild answers are there. But he was lucky. He was lucky once, and he produced correct answer, and he's rewarded for that correct answer, even if that was just a fabrication. So the model, in this case, learns that this is the strategy that the humans are expecting, because I get more points from it. So what we are basically doing with this evaluation process is we are creating a professional guessers, a professional tricksters, because the model learns that this is what we are expecting based on the binary evaluation. So as the research paper reveals, the ultimate reason why the models hallucinate is because at the moment, we have no way of telling them, good job, if they answer, I don't know. So we don't have this kind of like a feedback loop with them based on the binary evaluation. And the problem basically goes even further. You can see here is a list of different benchmarks that we are using to evaluate the models when they're already trained. So these are ways how we can evaluate already finished models, and these are valid used benchmarks, as you can see, and basically all of them except one are using also binary evaluations of the models. So we are also, they are getting the higher score when they are rolled out, and this is how we are evaluating them, and only one of all of them is partially rewarding the I don't know answers. So also the problem so far was even further than just training. It goes beyond the training process. And here is a very nice picture of how it looks in the data. So the first picture is the calibrated model after the pre-training, and the second one is after the post-training. And what you can see here on this axis is a percentage of how many times the model produces a correct answer. And on y-axis, you have how certain the model is that he is producing a correct answer. And as you can see from the pre-training, even if the model from pre-training comes out very well calibrated, so for example, if he is 60% sure, he should be right in about 60% of time. So that's very well, because the model is aware of his weaknesses. But after the post-training, you can see that we are producing overly confident models. So even if the model is confident 90% that he is correct, in reality, he's only correct for about 50% of the times. So we are producing overly confident models that are trying to guess and they are trying to please us regarding their answers. So right now, hopefully, with this new information that comes up, we will be able to modify our training process and produce something that will be more suitable and produce much, much less hallucinations. So basically, to sum it up, the reinforcement learning with binary ratings are pushing model basically to be much more confident that it should be in the practice. So because we have like no way of telling them good job for I don't know answers. And just to sum it up, so hopefully as we as a persons learning this, that like the true intelligence doesn't come up from knowing everything, it also comes up from the knowledge of where the limitations of my knowledge are. Hopefully, if we manage to teach this to a machine, hopefully we will remember it better ourselves. So, thank you very much.